Hi, so we are still with the different theorems of limit of a function. So for theorem 6, it's called the quotient theorem or division theorem. So it states that the limit of quotient of two functions as x approaches a certain value of c is equal to the quotient of their limits. So if we have limit of f of x divided by g of x as x approaches c is equal to the limit of f of x as x approaches c over or divided by the limit of g of x as x approaches c. Let's work on some examples. If limit of f(x) as x approaches c is equal to 4 and limit of g of x as x approaches to c is equal to -5, find the limit of f of x over g of x as x approaches c. So using the theorem, we'll get the limit for each function. So the limit of f of x as x approaches c divided by the limit of g of x as x approaches c. Our f of x is 4 and our g of x is -5. Therefore, the limit of the quotient of these two functions is -4/5. The limit of x plus 9 over 6 minus x as x approaches 3. So what we can do here is we can evaluate the limits of the numerator and then the denominator. So for the numerator, we have the limit as x approaches 3 of x plus the limit of 9 as x approaches 3. And for the denominator, we have the limit of 6 as x approaches 3 minus the limit of x as x approaches 3. And then we will apply the different limit theorems that we learned. So for the first one, this is equal to 3, right? Plus, this is a constant limit, so limit of a constant, so that's 9, over, again, limit of a constant, it's 6, minus the limit of x as x approaches 3, that's equal to 3. So 3 plus 9 is 12 over 3. 6 minus 3 is 3. So the answer is 4. Let's have another one. The limit of 3x plus 4 over x plus 3 as x approaches 2. So applying the quotient or division theorem, this would be the limit of 3x plus 4 as x approaches 2 divided by the limit of x plus 3 as x approaches 2. Okay, and then we'll apply all the previous limit theorems that we learned. So for the first one, we'll have 3 times the limit of x as x approaches 2 plus the limit of 4 as x approaches 2 divided by the limit of x as x approaches 2 plus limit of 3 as x approaches 2. Okay, then let's simplify over here. So this one would be 3 times 2, okay, plus limit of a constant is 4. So over, so this one, the answer is 2 plus, and again, limit of a constant is 3. So 3 times 2 is 6, plus 4 over 2 plus 3 is 5. 6 plus 4 is 10 over 5. So therefore, the answer is 2. Please note that for the quotient or division theorem, the limit does not exist if your g of x is equal to 0. So we know that if a limit of f of x as x approaches c and limit over limit of g of x as x approaches c, and if this denominator is 0, the g of x is 0, and let's say we have a value and the limit does not exist. If the numerator and denominator are both equal to 0, so let's write it. Let's say f of x as x approaches c over limit of g of x as x approaches c. Let's say the f of x is 0 and the denominator is 0. In this case, the limit may or may not exist. Okay. For theorem number 7, it's called the power theorem. It states that the limit of the n power of a function equals the n power of the limit of the function. Let's have an example. The limit of x plus 1 squared as x approaches 5. Applying the power theorem, so this is equal to the square, okay, square of the limit of x plus 1 as x approaches 5. Okay, so then let's simplify. So we have the limit of x as x approaches 5 plus the limit of 1 as x approaches 5 raised to the power of 2. So we know this one from our previous theorem. So this is equal to 5 plus, and this is a constant, limit of a constant, so that's 1. And this is raised to the power of 2. So 5 plus 1 is 6 squared. So therefore, the answer to this limit is 36. Another example, the limit of the cube of 2x plus 3 as x approaches 2. Applying the power theorem, so this is equal to the cubed of the limit of 2x, let's separate 2x plus 3, as x approaches 2, plus the limit of 3 as x approaches 2. Okay, so this will be equal to, applying our previous knowledge of the limits, so the first one will be 2 times the limit of x as x approaches 2. And this one is limit of a constant, so plus 3 raised to the power of 3. Okay, and let's simplify this. So it's 2 times this one. The answer of the limit here is 2 plus 3 cubed. So 2 times 2 is 4, plus 3 raised to the power of 3. So this will be 7 cubed, which is equal to 343. For theorem number 8, it's called the radical or root theorem. It states that the limit of the nth root of a function as x approaches c is equal to the nth root of the limit of the function, provided that the nth root of the limit is a real number. So if our index n is an even number, we'll get a positive answer. If our index n is an odd number, we might get a negative answer. Let's have some examples. Find the limit of cube root of f of x as x approaches c if limit of f of x as x approaches c is equal to 8. So applying theorem 8, we'll have the cube root of the limit of the function. So the limit of f of x as x approaches c. And our f of x is equal to 8, so that's the cube root of 8, which is 2. The limit of the square root of x squared plus 5 as x approaches 2. So applying radical theorem, so this would be the square root of the limit of x squared as x approaches 2 plus the limit of 5 as x approaches 2. Okay, let's evaluate. So square root of, so this one, x squared. So we substitute our x as it approaches 2. So that would be 2 squared plus, this is limit of a constant. So that's 5. So we have 2 squared is 4 plus 5, which is the square root of 9, and that is equal to 3. For theorem number 9, this is the limit of a polynomial function or a rational function. So if p of x is a polynomial, then the limit of p of x as x approaches c is equal to p of c. And if we have a rational function, let's say the limit of p of x over g of x as x approaches a would be equal to p of a over g of a. So in other words, we'll use direct substitution. And please note that if we have a rational function, our g of x should not be equal to 0. Okay, let's have some examples. So the limit of 9x cubed minus 7x squared plus 2 as x approaches 2. So in this case, our polynomial function is this 9x cubed minus 7x squared plus 2 as x approaches 2. So therefore, this is equal to f of 2. So we have 9 times 2 cubed minus 7 times 2 squared plus 2. So 9 times 8, 2 cubed is 8, minus 7 times 2 squared is 4, plus 2. So this is equal to 72 minus 28 plus 2. This is equal to 46. Limit of 2x minus 14 over x plus 1 as x approaches 7. So this is equal to f of 7. So this is equal to 2 times 7 minus 14 over 7 plus 1. So 2 times 7 is 14 minus 14 over 7 plus 1 is 8. 14 minus 14 is 0 over 8. So the answer is 0.